Well, welcome back, folks. We've just had a wonderful talk from Martin Porter and great exchange in our question and answers. And it's my real privilege now to introduce and welcome to Professor Chris Dent from Edge Hill University, which is, for those of you who are not familiar with the northwest of England, is just outside Merseyside, where Liverpool is, but we always think that there are 4 universities in the sort of Merseyside area, Edge Hill is probably the leading university now, I would have said, in the sort of area. But it's great to welcome Chris. Chris, apart from being a professor at the university, also took the initiative 2 years ago, and I've been privileged to be a small part of that initiative, to develop something called SustainNet. And SustainNet is bringing together, I don't know, is it about 17 different universities and higher education institutions, maybe more, across the northwest of England. So a small part of the globe, but a very significant one as far as we're concerned. And the purpose of SustainNet, which I'm sure Chris will say a little bit about, is really to bring that solidarity that Martin was talking about in his address, to bring that solidarity amongst academics, amongst students, amongst activists within universities and higher education institutions together around the sustainability challenge. So it's great to have Chris with us. Chris's title is Trade, Energy and Climate: The Key Challenges Ahead. So welcome, Chris. Thank you.
Thank you very much indeed, Tony and Catalina, for that very warm and wonderful welcome. It's my great honor and privilege to be with you here today to talk about trade and energy and climate action. So I'm an international political economist. I've had a long-standing interest in trade, in free trade agreements in particular, and also a very long-standing interest in renewable energy, and thereby climate action. So in my talk today, I'm really covering the kind of key area of expertise that I have at the moment, which is on trade climate issues, how trade can play a key role in addressing climate change and action. So what I'm going to do now is share my screen, and actually what I do first of all is set up my screen to be shared. How about that? That's probably a good start, isn't it? So I just go to the start of the talk, back to Zoom land, and just talking to fill in time, and then press share screen. And then here we go. So the title of my talk, ladies and gentlemen, is Trade, Energy and Climate: The Key Challenges Ahead. So let me first set the scene of my talk. Now, as we know, energy is at the center of climate change and action. And what I'm going to do at the first part, it's like a talk in 2 halves that kind of converge together at the end, I guess. But what I'm going to do in the first part of my talk is talk about recent developments in renewable energy, clean energy generally, and where do we go from COP26 onwards. I'm then later going to talk about trade's connection with climate action. Now, why am I doing that? It's because trade is an increasingly defining feature of the global system and the global economy. So if you were to go back to the 1970s, trade represented about 30% of global GDP. By the 1990s, it represented 40%, and now in the 2020s, trade accounts for 60% of the global economy. Now, I can talk about the kind of aspects of that, composition is that, why is trade growing so fast? It's all part of the broader development of the globalization of the world economy. So I can take questions on that later if you like, but we're going to explore trade's connections with climate action and trade in some detail later on. Now, what's interesting is that even though trade is becoming increasingly important to how we organize economic activity on the planet, and thereby having greater connectivity with climate action and and change is that there has been still relatively little work done on this area, on what I call the trade climate nexus. I'll be going into a bit more detail about that a bit later on. And also I'll be talking about trade's rather complex relationship with the environment generally and with climate change. And we'll see that when I talk about the trade climate nexus, that energy is very much at the center of that kind of relationship, that dynamic, and I'll be exploring that a bit later as well. So I'm going to first look at energy related issues, then look at trade, and then bring things together towards the end. Now, I'm sure you've all seen some kind of graphic like this, showing how energy is at the very core of greenhouse gas and carbon emissions more generally. So this is a graphic showing you some really important points that I'm going to be referring back to a bit later. So by energy, oops, sorry, no, wrong button. By energy, what we're looking at here are three main kind of sectors, three main uses of energy. So there's power or electricity generation. There is thermal heat, which is very relevant to industry. And then thirdly, there is transportation. Now, you can see that energy here, and it's divided up into different kind of sectors, covers a wide range of different activities. So if you take, for example, at the top at about 12 o'clock, 12, you can see that the iron and steel sector alone accounts for, according to this estimate, it's a 2016 estimate, current estimates are around 7 to 9% of global carbon emissions. Okay, so that sector alone is 3 times, for example, around 3 times more than global aviation, for example, in terms of greenhouse gas emissions. Then you've got kind of other, you can look at the detailing yourself here. You've got aviation, shipping, road transport there in terms of their contributions to global greenhouse gas emissions, energy use in buildings. So heating, that also includes electricity as well, and various other things. And then you've got other sectors up there, which also make a contribution to greenhouse gas emissions. Apologies for any background noise. I'm at home and someone has just arrived. Sadly, not with any goodies, but anyway, there you go. So now let's look at renewable energy and what's been happening to that in terms of global energy developments. So what we have here are some data from the Renewable Energy 21 Policy Network, or REN21 network, which every year produces something you can just see at the bottom of the slide, the renewables global status report. So these come out every June. If you want to know about renewable energy and what's been happening on not just kind of power generation, electricity, but all kinds of use of renewable energy, then I strongly recommend you to look at this free resource. Comes out every June. I also do some work for REN21, so I'm kind of plugging their work a bit here. But they produce some really great communicative graphics, which give you a very good overview of what's been happening. So what we have here is 2 bar charts, and this is showing the share of, or how the different types of energy break down by total energy consumption. That is combining all forms of energy consumption and production together into one consolidated kind of figure, and it's done in kind of terajoules or terawatts of energy. So you can see that about 10, 11 years ago, 2009, that renewable energy made up, and this is looking at transportation, power, and thermal heat, only 8.7% of total energy consumption production. That has only increased over the last decade to 11.2%. So some increase, but not a huge change. Moreover, you can see that fossil fuels share at about 4/5, 80% of all the energy we use on the planet as a civilization has stayed the same. The others is mainly nuclear and other forms which have kind of contracted over time. Then you've got a breakdown of where this power is coming from. So biomass, you can still see, is actually a biggest sector there. That's mainly used for thermal and a bit for transportation. Hydropower, wind, geothermal, solar is used for power generation. Now, what's important to note is that, and again, I've got here in this slide, you can see I've broken down the energy sector into 3 different components, is that when we talk about renewable energy and when it comes in the media, what is the first image that they use? What they will use is typically a row or an array of solar panels or these big wind turbines, either offshore or onshore. Now, this is great, and I'm going to show you later how fast these sectors are growing and how important they are. But the solar and wind are only concerned with the power sector, and you can see that currently, the power only represents 17% of all the energy we use on the planet. So when we're talking about wind and solar, it actually only focus on quite a small part of what energy we use generally. Thermal heat represents 50%, about 3 times the amount that we use for power. So the thermal is really, really important and much overlooked. Transportation at 32% is a much bigger sector in terms of total energy used than the power generation sector. So this is the key point one of the key points I wanted to make, is that yes, solar and wind have been growing very fast. Yes, so have other kind of renewable energy technologies on the power generation side. But we tend to overlook the fact that on thermal heat, there is still massive loads to do, especially in industrial process heat. And I'm going to come on to that a bit later to give you a bit more detail. On transportation, you can see that the transport sector, about 97% of it is fossil fuels. Biofuels make up like biodiesel, bioethanol, 3% of that, and then 0.3% is renewable energy, that's EVs. So that's how much of a dent they're making on that sector. Still really, really small, even though the sector is growing very fast, but from a really, really small base. So I just wanted to put that in context. These are where going from COP26, if we want to decarbonize energy, we need to get a more accurate picture of okay, what do we need? What do we really need to do? Where do we really need to kind of put our priorities going forward? Now, I wanted us to first talk about the energy sector where renewables has made the most progress, and this is in the power sector or electricity or power generation. And just some key things to note here. So the figure of 27.3%, so that's of all the electricity that's generated on the planet, over a quarter of it now comes from renewable energy sources. Now, if you were to go back 10 years, that figure would be around 22%. So yes, there's been progress. Yes, it's higher than it was, say, 10 years ago. But you can still see the extent to which we rely on fossil fuels for power generation. And I can take some specific questions on that, on what's happening, say, for example, in China, what's happening in other countries, on other parts of the world. One other thing to note is that of that 27.3%, well over half of it still comes from hydropower. And much of that comes from countries like China, Brazil, India, Canada. Norway actually relies 97% of all of its electricity on hydropower, right? So it's interestingly, hydropower was the original electricity power grid technology when national grids were established over 100 years ago. Okay, so this was hydroelectric dams were the first way that we could actually generate electricity for regional and national grids, and is still very dominant. Wind and solar are there. You can see their shares are growing, and I'm going to give a bit more detail on them a bit later on. In fact, here's a little bit more kind of generalized data on what's been happening to renewable energy, where the the gains have been. Now I need to just move my Zoom screen out of the way because it's kind of covering the key. There, I can see it better now. So, okay, where have the net annual additions of renewable energy capacity? So what we're talking about here is, when we're talking about capacity, installed capacity, we're talking about what is the maximum power these things can generate if the sun, for example, was shining on a very sunny day, if we had good wind resources. So capacity is different to production. So it's a little bit like, you know, like a battery. The capacity of the battery will, you know, like on your laptop, can last for 7 hours. But we need to talk about how much are you using that battery, right? So capacity is to do with the potential power of these technologies to produce actual power. Now, you can see that solar is where there's been really massive growth. It's been the fastest growing sector in the last 20 years. Wind power is also increasing its net capacity globally. Hydropower is coming down a bit. That's mainly because China is not building so large hydropower dams like the Three Gorges Dam on the Yangtze. And biopower, geothermal, ocean power, and CSP is concentrated solar power. They only make a relatively small contribution. So a bit more about those kind of more niche renewable energy technologies and what's been happening with them. So whereas solar and wind have been growing at like 10, 20% a year, and hydropower somewhere between 3 and 10% a year the last 20 years. Biopower is mainly used for electricity, well, when it's used for electricity generation. So using wood pellets, municipal solid waste and stuff to generate power, but the kind of growth rates have been only between 3 and 5%. Geothermal's been lower than that, about 1 or 2%. And then ocean power, we're talking tidal wave and ocean thermal currents. These still remain very experimental. And there's only a few installations, mainly tidal barrages, which are actually networked to the grid and actually making any difference. So within the renewable energy technology spectrum, there is a wide range of different rates of progress, both in terms of install capacity increases and also in terms of technological developments. So this is why we get so much attention on wind and solar, because these have been the two stellar performers in the last 20 odd years. So let's look more specifically at what's been happening to solar power, solar PV, photovoltaics. So in the solar energy spectrum, you have 3 subsectors. The biggest is solar PV, like solar panels generating electricity. You can also have solar concentrated power, or CSP, concentrated solar power, which are using hyperbolic mirrors to concentrate the sun power, which is directed then to a chamber which heats up water to steam and then drives a steam turbine, just like you get in most thermal power stations. And then you've got solar thermal or water heaters. But solar PV is where the action is and where most of the attention is. And you can see that globally it's been rising very, very fast. So from 39 gigawatts to 760 within the space of a decade. Now, to put that in context, what does 39 gigawatts of power actually mean? The UK's national grid capacity is around 95 gigawatts. If you go to China, it's about 1,200 or 300 gigawatts. So this is theoretically enough to cover 8 kind of Britons, you could say, or 8 UKs. Why has it been growing so fast? A number of reasons. It's becoming very cheap. So if you look at unit costs of solar PV now, they are 15% what they were 10 years ago, right? So they've become 7 times cheaper within 1 decade. Why is that? Mainly because China is mass producing them on a huge scale. So whereas if you go back to 2004-05, China made 5% of the world's solar panels, they now make 70%. Another reason is because the efficiency of these are growing as well. They're becoming better, more able to convert sunlight into usable electrical power. So the technologies become better and cheaper, really, really cheap. And that's why it's expanding so fast. I can also take questions on higher tech solar, like second and third generation solar. That's really exciting, like integrating solar PV into windows, right, to generate electricity, for example. So that's solar PV in a bit more detail. Now let's move to the world's second largest and second fastest growing energy sector, which is wind energy. Now, again, you can see good steady rates of growth over the last decade. And in fact, solar overtook wind. You can see there by the total gigawatt installed capacity figures for the first time, even though wind actually generates more power to the grid because it's able to convert energy more effectively. And so wind is still generating more power to us all. But theoretically, the solar power capacity is larger than wind's now. So what's interesting about wind energy is that it's got a still small but fast growing offshore wind sector. And whereas China here dominates the production and installation on onshore wind and of turbines generally, Britain is quite well positioned here in terms of offshore wind. In fact, it accounts for about a third of global wind power capacity. There's an image of, on the left-hand side, you can see where the main offshore wind farms are located, mainly on Britain's east coast, here in the North Sea section. You can see the Danes, who have been they were the original industry leaders of this sector. They developed wind power back in the 1900s. And you can see that on the technology side, the main advances on wind turbines is that have become increasingly large. Now, there is an image here you can see with images of large wind turbines next to quite well-known tall constructs. So I'm not sure what that is. That's probably St. Paul's Cathedral. That's probably the London Eye. That's the Gherkin in the City of London. I was going to say that's Blackpool Tower, but I think that's probably the Eiffel Tower in Paris. And then I guess you can all recognize this one, those of you who know London quite well. That's the Shard, the tallest building in London. And these are the kinds of wind turbines they're developing now, up to 15 up to 15 megawatts. Now, one 15 megawatt turbine can produce enough electricity for about 20,000 homes in the UK equivalent. So you can get a feeling for how much power these things can generate if you were to put hundreds or thousands of them together in one location in the North Sea. So very promising developments on the wind sector as well. This is from the RE100 group, which is a group of companies that have committed to source their power generation 100% from renewables. And they do some interesting analytical work. And what we got here is a kind of a graphic showing you how cheap and competitive wind and solar power is now in these different national markets. So if you go back to 2014, you can see that coal and gas were by far the cheapest forms of electricity in those countries there listed. And wind was only the cheapest energy option in Denmark, Germany, and Uruguay. But if you go to 2019, you can see how the situation has changed. And picking out the UK there, you can see that wind, offshore wind or onshore wind is actually the cheapest form of generating electricity. It's even cheaper than generating it by gas or coal in our country because it's become so efficient. So it's making good penetration into the renewable energy sector on the on the power generation side. Now I can take some questions about the challenges revolving around intermittent energy sources like wind and solar. But this is showing, this next graphic is showing you the where the new net additions of power generation capacity are being added globally. And you can see that renewable energy, in terms of new power stations being built, whether that's a wind farm or a solar park or a hydropower dam, that renewables, their share of new capacity added is increasingly rising. And so that is also very encouraging, okay? However, if we go back to one of the earlier graphics I showed you, showing you the 3 different energy sectors, right? So power, transportation, and thermal. You may recall me saying that thermal heat energy represents 50% of all the energy that we actually consume on the planet. Now, if you take the emissions from the industrial heat sector, they account for 25% of all global emissions. So, why is industrial heat needed, and why cannot electricity supply the energy needed in an industry like iron and steel? A lot of it is to do with physics. So when you are trying to melt iron and convert it into steel, you need to heat up the iron ore to 1,200 degrees Celsius. Now, you cannot reach those temperatures in an electric arc furnace, which can only get up to about 800 degrees Celsius. Now, you can do aluminium that way, but you cannot, it doesn't generate enough heat and power and energy to convert iron into steel, and also other elements into chemicals and cement that we produce. You need very high forms of high levels of process heat. Now, this just gives you an idea of these different industrial heat processes: iron and steel, cement, chemicals, aluminium, food and tobacco, pulp and paper, and what energy is used in the processing of those industrial materials. So you can see that for iron and steel, coal is used around 85%. For cement, it's up to about 70%. For chemicals, coal is around 30%, but also oil and gas are used. So, the green and the 2 grays represent fossil fuel use in these in these industrial sectors. In aluminium, you can see that electricity is used because of the use of electric arc furnaces, but then it's a question of how do you generate the electricity? So, for example, in China, where half the world's aluminium is made and also half the world's steel, they're generating an increasing share of that electricity for the electric arc furnaces to convert bauxite into aluminium using fossil fuel power stations, which is a pity. So how do you actually decarbonize these sectors? I just need to put my charger on, talking of batteries earlier. You'll be pleased to know that I've got solar panels on my rooftop. So this presentation has been brought to you by Green Energy. And it's a relatively sunny day here. So how do we actually decarbonize these sectors? The key challenge is getting the process heat levels. And at the moment, green hydrogen is the only kind of option. And of course, we've got different ways of producing green hydrogen and renewable energy through electrolysis processes is the way forward, but it's still quite expensive, and I can take some questions on that. But this is the key area for us decarbonizing these overlooked sectors where we're really generating emissions, where we're not making too much progress. Okay, so that's on energy. I wanted just now to move on quickly to trades. Now, there has been quite a bit of work on trade environment. So I'm going to just talk through what the positive impacts of trade on the environment generally and on climate change, and then some negative impacts. This is kind of stuff that has been done before. I'm just kind of summarizing the arguments on both sides. So on the positive side, let's be optimistic. How can trade help climate change, and how can it have a beneficial environmental effects? Right, so first of all, trade can lead to improved environmental resource efficiency due to allowing countries and companies to specialize according to their comparative advantage virtues that they have. So you allow the more efficient companies to produce by having an open trade system and countries specializing according to their comparative advantage, and then they use less inputs, less material inputs, less emissions, and so on, right? So the more efficient producers prevail in an open trading system where countries and companies are allowed to trade their surpluses. You could also say that in more liberalized trade conditions, more efficient and competitive producers of environmental goods and services like solar panels and wind turbines are able to expand. And this also helps to spread the technology. It kind of has a beneficial eco-technology transfer effect. And lastly, trade can help raise income levels and capacity levels in developing countries that enable them to prioritize environmental goals in a better way. And this is the kind of environmental Kuznets curve argument. On the negative side, though, you could say that trade-driven economic growth expands economic activity and subsequently increases carbon and other greenhouse gas emissions. When we produce, when countries are producing more steel because there is demand for their exports, exported steel because it's so competitively priced, this will have an impact on increasing greenhouse gas emissions. There can be other environmental problems caused by trade expansion, especially if it's linked to urban industrialization, right? So if you look at Asia, you've got some very good examples of that. Export-driven economies, not just China, but also South Korea, Taiwan, Singapore, Malaysia, and so on. Traders help their has kind of spurred urban industrial development, and this has created various levels of environmental problems like air quality and so on. There's also the kind of Jevons paradox kind of argument in that trade-induced efficiency gains, yes, it does help us to produce more with less material. However, it also makes goods more affordable and cheaper to buy, and therefore leads to greater mass consumption and more material demand. So actually can have a kind of a backlash effect by becoming more trade-induced efficient. And then lastly, of course, there's transportation emissions. Now we've just signed or in the process of signing a free trade agreement with Australia. Now, if you were to export beef from, say, Sydney Harbour and it arrives at Felixstowe Port, it takes 56 days and there's a transit distance of 13,526 miles. Now, why would you want to do that? Why would you want to do that when you can just get beef from your own farms in your own country? Why send beef literally halfway around the world, okay, from one location to another? Now, this is why I kind of mentioned at the beginning how trade is very important to think about in climate change, because we are moving more and more stuff around the planet because trade is increasing. And 40% of all we trade is actually parts and components. It's not just finished products. It's actually materials and parts that are organized in international supply chains and production networks by multinational firms, producing goods with a multiple country division of labor. Now I can see that Tempest is fugiting, time is flying, and I will just quickly mention carbon leakage. This is to do with, this is kind of trade related as well. And this is connected to foreign direct investment, so kind of trade investment linkages. And carbon leakage is where companies will relocate their production or other forms of business activity from countries that have relatively high environmental and climate standards to those which do not. And therefore the compliance costs of meeting those standards is lower. They can produce things more price competitively, because they need to, because they are competing in the international market in an open trade system. So this can have kind of negative effects, and it's sometimes difficult to estimate, when countries and governments try to estimate carbon leakage effects. But this can create pollution havens and a race to the bottom of environmental degradation. Bottom environmental standards, and lead to environmental degradation outcomes. And it tends to arise in energy intensive industries, right? So one of the reasons why the UK has had falling carbon emissions since the 1980s is linked to a point that Martin made earlier about deindustrialization. That's been the biggest single contribution to Britain's carbon reductions in the last 40 years, is deindustrialization, because our companies have shifted elsewhere, or we just don't make kind of carbon intensive products as we used to anymore. So if you look at Germany, still an industrial country in many respects, has a higher carbon emissions per head rate than we do for that reason. Okay, now trade-related greenhouse gas emissions, just very quickly here. So you can look at this from different perspectives. The scale effects tend to have a large effect on, or an increased effect on carbon emissions because of more economic activity induced by trade. Composition effects tend to have a kind of a negative effect on well, can have a negative and positive effect actually on trade emissions, because it's to do with the structural changes that have had more trade happening. Now I've got a small graphic to kind of show you that. Technique effects tend to have a negative effect on emissions from trade because of the increased efficiencies I mentioned earlier, and about greater eco-technology transfers. Now, on the scale and composition effects and connecting this to trade, this is an estimate produced by the UK's Department of Trade, Department of International Trade, on the emission impact of the UK and Australia signing a free trade agreement, which would lead to greater trade between the countries. And you can see that they've got kind of the carbon emission effect, and then the non-CO2 emissions, which are things like methane and nitrous oxide. You can see on the scale effect, the increased trade between the two countries lead to greater emissions generally, especially on the CO2 side, but there's a reduction on the non-CO2 emissions. And this is because the Australians will be selling us more beef, and therefore there'll be less methane from less cows in Britain, because we'll be buying beef from Australia and not producing it ourselves. And that's the kind of net effect. Plus, on the carbon emission side, negative on the non-carbon emission side. So these kind of things occur. Now I've seen the time, crikey, it's really moving on, isn't it? So look, let me press on. What's been happening with trade climate diplomacy? In short, on the UNFCCC, so I missed out a C there, apologies for that, missed out the change bit. Virtually nothing. UNFCCC has had nothing to say on trade. If you look at all the documentation, it's just got nothing. What it tends to do is defer this to the WTO, which has far more kind of governance capacity, because it can set rules, right? And so on and so forth, although it hasn't made any rules for the last 25 years, really. And also to the United Nations Environment Programme, OECD and World Bank. And those organizations have largely ignored trade climate over the last decade, but have come back very recently with some reports. So it's been a much neglected area in terms of global governance. What has stepped into the vacuum are free trade agreements. Now, the WTO, I'll come on to that in a moment. The WTO's trade and environmental sustainability structured discussions were launched last year. And this is a sign that the WTO is starting to take trade and environment kind of seriously again, and also trade climate more specifically a bit more seriously. But still, there are no global trade rules on climate action in the WTO. And if you look at where rules have been included in free trade agreements, these remain relatively weak, as I'll kind of show you in a moment. So free trade agreements have become important because the WTO hasn't really done much. It's been inert on various fronts. So FTAs, which are kind of preferential agreements signed between countries, have been on 20 years. You can see the cumulative number that in the black line there has increased to the late 1980s. There were like a couple of dozen of them, right? So FTAs have been setting new rules and structuring trade in the world trade system for the last 20 years. Now, I'm just going to flick through some things here. This is what I've been trying to do, is trying to establish kind of empirical domains on the trade climate nexus. What kind of rules can be brought into trade agreements to help enhance climate action on this front? Those are the ones I've listed, and what I've done is a bit of research on all the FTAs that have had climate relevant provisions, and I have classified the different climate relevant provisions into these 14 different types. Now, to connect up to COP, you can see the ones in the pink, type 12, 13, and 14, relate to whether these free trade agreements cross-refer to commitments made at UNFCCC and specifically to Kyoto, and there's been a few agreements that have done that, and also to Paris COP21. Now, if you look at the data and the patterns of countries, trade partners that have included climate relevant provisions into their free trade agreements over the last 30, 40 years, you've got the kind of size of block there, and also the denser shade of blue, as indicating these are big trade partners with hubs of this climate relevant trade provisions in their free trade agreements. The lines between the different trade partners indicate the kind of bandwidth of provisions between those trade partners in their FTAs on climate relevant provisions. So they could be, like, for example, promoting renewable energy or to cooperate on greenhouse gas emissions, commitments of those nature. That was the picture in 2010. Okay, the picture of climate relevant provisions between these different trade powers. This is the picture in 2020. So you can see there have been more trade powers and partners that have included FTAs with climate provisions, and the bandwidths have increased. I've done some research on who is doing what. The European Union is the standout, as you can see. United States not doing so well, but only 48% of FTAs which the EU has signed have actually got anything on climate included in them. If you go for the last 10 years, that's increased. So there is a kind of, it's gradually becoming the norm in this most important aspect of trade diplomacy, FTAs, because nothing is really happening on the global front at the WTO. So that's an overview of my talk. There's a few points to summarize it. I'll leave that up whilst I now hand back to my very understanding hosts, because I've gone about 14 minutes over the time allocated. So apologies for that. My enthusiasm got the better of me. But over to you, Catalina and Tony.
Okay, thank you. Thank you so much. This has been a great talk. Really learned a lot about your research and the work you've been doing. Thank you so much for that. So now we are going to take some questions from the audience.